All right, today we're going to be solving equations involving radicals, but these ones are going to be a little bit more complicated, a little bit more complex. I'm also going to ask you to do a little bit more work as you go along. Notice up here at the top of the screen I have YD equals you do. So there'll be a portion of this assignment that you will complete on your own, so please make sure that you are doing this. Be diligent about this. Get your practice in before you come to class tomorrow so that you can either ask questions or feel good about where you're going with this. Additionally, there'll be some error analysis pieces that we go ahead and look at as well. A very important strategy that we have to make sure that we understand is our perfect square trinomial. So I'm going to begin with that. A plus B quantity squared is A squared plus 2 times A times B plus B squared. So you're going to really want to have a firm grasp of this before looking at these videos in depth. Plus B squared. All right. Since this is a you-do problem, I'm going to use some of this space right here for that. You would not want to use the space underneath because you need some. But let's go ahead and practice this real fast. A plus 4 squared. Well, that becomes A squared plus 2 times 4 is 8. A plus B squared, which is 16. All right. And now we're going to use it in the context of what we'll have today. So that's going to be, let's say, 2 plus the square root of x minus 3. We'll use that as our example. So A is going to be 2, so 2 squared is 4. 2 times A times B. So A is that, so 2 times 2 is 4. B is that, so we're going to multiply it by the square root of x minus 3. And B squared is the square root of x minus 3 squared, so that's going to be x minus 3, because those two symbols will cancel each other out. And so that perfect square trinomial is going to help you a lot today when you're looking at these particular problems. Okay? All right, so in this particular case, what you're looking for here, and in all cases, you're looking to get one radical on one side of the equation and the other radical on the other side of the equation. We're going to have to deal with the numbers that go along with it in whatever form they come in. So in this particular problem, notice there's multiplication involved. So this one's going to actually not involve the perfect square trinomial. This goes back to properties of exponents. Remember, each one of these is an individual in multiplication, so that means that it's going to be 4 squared and then the square root of x plus 1 squared. And we know that those two symbols will cancel each other out. That's going to be 3 squared and the square root of x plus 2 squared. And we know that those two symbols will also cancel out. So in this first one we get 16 times x plus 1. And this second one we get 9 times x plus 2. And we'll go ahead and distribute that through. 16x plus 16 equals 9x plus 18. I'm going to go ahead and move the 9x because it's smaller. That means I have to move the 16. And that's going to leave me with 7x and 2. I'm going to divide out the 7, and I get x equals 2/7 as my final answer. I can't solve or move on from this problem yet until we get our Boolean algebra test put together. So I went ahead and incorporated that already into my calculator to prove that it is a solution. So you can see how that all works. We've had that practice before, so I'm not going to spend a lot of time on it. It does check out. So always check for your extraneous solutions, regardless of what type of problem you're working on. Use that strategy to solve number 1. Okay, the next thing I want to do is I want to incorporate some error analysis techniques into the next two problems, okay? So I'm going to explain this, and I'm going to ask you to pause the video so that you can look through this and figure out what the error is, if there is any. So please just take a look at the work, go through each step carefully after I get done explaining it, and determine if there's an error. If there is an error, please determine the step in which the error was made so that we can figure out where it is that these people, well, this would be me, have gone wrong in this particular case. Okay, so notice what I did first. In number 3, the radicals were on the same side, so I put the other one to the right side. I squared both sides, and then I used that difference of, or perfect square trinomial to simplify this out. I get a squared plus 2 times a times b plus b squared. Then I moved this to the other side. I continued by moving the 9 to the other side. I multiplied this out, or I squared both sides to get rid of the radical. Distributed. Moved these numbers using PEMDAS, or opposite operations. Got a GCF, factored, and came up with the solutions. Likewise, since both radicals were on either side of the equation, I squared both. Again, utilized the perfect squares, went through the problem, simplifying in the same way that I solved number 3, and came to a solution. Please pause the video now, take the time to copy this down, get the practice in these steps so you can see what it looks like, and then analyze it for any errors. If no error was made, then of course, write no error. Otherwise, determine which step the error occurred in. All right. Hopefully you've taken time to seriously look through those error analysis pieces. Now what I want to do is I want to incorporate some graphing tools to help you see a slightly different point of view on how to solve these things as well. So I'm going to go into Desmos now, and once we're in there, I'm going to look at each one of these individually. So we'll start with question number 5, show you that they're there so you know what you're looking at. And now, when you're looking from the point of view of graphing, all you need to do is determine the place where the two lines intersect one another. It's a very useful tactic, even if we're asking you to solve using the lengthy algebra process that you saw in the previous sets of problems. And if you are being asked to solve algebraically, then I would automatically graph and therefore know exactly what the solution is. In this particular case, I'm solving for x, so I'm looking for the x value, and the x value at this point is 2. So the solution to this problem is x equals 2. That way you would know, if you went through the process and you got the answer 2, that you were correct. You would also know that if there were any other answers in addition to the answer 2, that they are automatically extraneous. Okay? The graphing tool is a very useful way for you to solve these problems, even if you're asked to solve by using algebra. Verifying is very useful when it comes to algebraic processes that are abstract like these. All right, we'll go ahead and take a look at question number 6 in the same way. That is question number 6, all lined up and ready to go, and I will light it up. So notice here that the lines are beginning to move closer and closer together. So we can't just rely on what we see originally. We've got to actually see what some of the end behavior is before we make our decision. And there we see it. The answer is n equals 27, because n takes the position of the x variable in this particular problem. What that means for us, if we're asked to solve algebraically, is if we go through a long process where we get the answer 27, then we know for a fact that that is the answer and we are correct. Additionally, we would know that if there were other answers that came along with it, that we would be able to clearly identify them as extraneous, because these two lines only cross each other exactly once. So while these are very useful tools, you're not always going to be able to use them solely as the way to get your answer, but you can always use them to verify, especially if you're stuck on a specific series of steps or problems. Okay? So please take the time now to graph this in your own graphing calculator, both 5 and 6. And I'd like you to draw a picture of what the intersection looks like in your calculator using your zoom features, especially for question number 6, because question number 5 shows up there nicely on the screen. All right, the last two problems, 7 and 8, will be for you to solve on your own. You may choose to do one in the graphing calculator and do the other using the algebraic method. If you are showing your work using a graph, then I'd like you to actually specifically draw the graph and show the intersection of those two lines, two curves, and how you found that solution. I'd like you then also to show obviously the algebraic steps for the other, so I know clearly that you are following the problems both algebraically and graphically, and that way we can move forward with some more complex work tomorrow. All right, in this particular problem, we're dealing with a word problem, which kind of gets us into a future lesson involving applications of square roots. And this formula is a formula that's similar to the ones that police officers use to determine at crash sites when an incident has occurred or an accident has occurred. They can actually determine how fast the car was going by measuring things such as the skid marks on the street and obviously the amount of damage that has taken place. But that's all mathematically solved and determined to verify whether or not people are telling the truth or their stories are not. So always be honest to your law enforcement officials, because they can solve problems mathematically to verify whether or not you are. Okay, so I'm going to go ahead and begin this by determining how far she'll be from the wall. So it's going to be 64 equals 21D. I'm going to square both sides of the equation to get rid of that square root symbol. I'm going to end up with 4,096 equals 21D. Divide both sides by 21. And I'm going to get approximate answer of 195.048. It's asking how far they'll be from the wall. Okay? And if the driver began to skid 200 feet from the wall, that means I will simply subtract 200 from 195, or 195 from 200, and it's said to the nearest foot, so I'm not going to bother with the decimal portion, and that means that the skid or the vehicle came to a stop 5 feet from the wall. All right, so make sure that you have your error analysis pieces for tomorrow. Make sure you have your problems that I've assigned for you to solve so that you are able to actively participate in tomorrow's lesson, especially at the beginning of class, asking questions and answering questions of your classmates.